Greetings, ladies and gentlemen. My today presentation will be not like the old ones. I will not give you any reference on GitHub, or I will not talk about any ready-to-use code. Rather than that, I will talk about some topics related to the deploying Zabbix infrastructure on the clouds. In my history of supporting people while I was employed by the Zabbix, I've seen a number of the attempts to deploy the Zabbix on the different clouds. And then working for other companies, I also witness and develop some other solutions. And that pretty much will be my description of my most recent path to the cloud deployment. So let's begin. Due to the time constraint, again, this will not be a presentation to give you a ready-to-implement solution. So rather than teach you how to play chess, I will tell you what the chess pieces looks like and what the board looks like. So also need to say there is almost no right and wrong solution during the system architecture because everybody's situation is different. So this experience which I put on this presentation pretty much summarize the proof of the concept I've done for Adobe systems. But your situation might be slightly different, depends on your situation. So, this is familiar to a great many of you. Zabbix frontend, Zabbix server, and Zabbix database. This is the classic Zabbix installation. And great many people who are tasked to, hey, you're system administrator, you're smart enough, do the monitoring for our company. And people taking the Zabbix, people deploying Zabbix server, database, and the front end, and things starts to working. Next, management start to have some ideas about deploying on the cloud. They asking, hey, now we need to deploy the same infrastructure on the cloud. And great many people, they taking the same thing, same 3 or probably more due to the proxies pieces, they just deploy them on the computing infrastructure on the cloud, and they think that their mission is accomplished. They deploy the Zabbix on the cloud, where in fact, everything wrong with this deployment. Because if you just take what you have as the standalones, in the standalone systems and just move this to the cloud, you will not receive scalable infrastructure. You will not receive fault-tolerant infrastructure. If your instance on which you run this Zabbix server failed, you don't have monitoring anymore. That's pretty much comes to this. Even the fact that you deploy this on the cloud. And this architecture still requires a lot of attention and manual intervention. Next, I'd like to demystify some of the abbreviations. Many of you probably know what this means, but again, as the part of the demystification, IaaS, PaaS, and SaaS. So first, what the cloud infrastructure provides to us, it is infrastructure as the service. So this is your network resources, this is your computing resources, this is your disk resources provided to you by the cloud provider. Platform as the service. This is the capability of deploying your custom application on the cloud. So this is not the part of the cloud deployment as per se. This is the part of your own deployment. And software as the service, that is the pieces, or software pieces, better to say, which available to you on the cloud platform as the service. So the principal difference is this is your part, and this is oftentimes provided to you by the provider. But again, there is no right and wrong. Sometimes this is I'm sorry, this is not entirely true. So, and how this is applicable to the Zabbix? Well, that's simple. IaaS covers your computing, disk, and network resources. Platform as the service, that you see familiar components, database, Zabbix server, proxy, front ends, GMX gateway. And the interesting thing starts here in the SaaS. In order to successfully and reliably deploy the Zabbix on the cloud, you need to address certain things. And you need to make the Zabbix play nice with the scheduler, container engines, message delivery queues, job queues, external aggregation, and other facts of the life. So what's important when you deploy your monitoring platform on the cloud? The same as for any other application. That your architecture shall be scalable. This means if you require more resources, you need to scale those resources accordingly without heavy downtimes. Fault resistant. Again, if the node on the cloud goes down or if the part of the cloud goes down, it shall not impact your application. And the decoupling. I probably will not cover decoupling in great details. Probably I will take this offline if you guys are interested. But this is also a very important portion of the cloud deployment. Your interaction of the software that you expose to the cloud shall be decoupled from each other. So they shall not directly depend on each other. So you shall not assume when you start to passing data from A to B that the B will exist and it will exist in specific place. So that's pretty much nature of the cloud, but we can discuss this later. So, and the difference from the standalone deployment and the cloud deployment that all your pieces, all the parts of your installation deployed somewhere on the cloud and you don't have any control whatsoever over IP address space or several other components you are accustomed to take care of yourself. And in the bottom, it is a resource discovery. We will talk more about this. It's very important because since those components may end up anywhere on the cloud, you do need to know how to find them. Next. So what is the SaaS has to offer for your installation? Very important. Container hosting and execution platform. Ideally, when you will choose the scheduler and the hosting platform for your Zabbix deployment, you need to think about which ones will support containerization, container orchestration, and legacy applications. And I will tell you, I find 2 of them which are doing that job exceptionally well. Fault tolerance schedulers. Schedulers, it's a piece of the software which pretty much deciding on which part of the cloud, like which resources of the cloud required to run the specific application or specific container. Resource discovery, again, it's a very simple. If your application or your container deployed on the cloud, you need to know how to find it. And message queue and delivery, again, I mentioned the decoupling. This is a bit of the anti-pattern for the Docker, and it's the first time I mentioned the Docker, most popular container engine as of now, at the time of this conference. And some people don't like in-container orchestration. Some people think this is anti-pattern. I find for the specifically for the Zabbix, which is not exactly container or cloud-aware application, sometimes you need to run some applications or some parts alongside with the main daemons. And for that purpose, supervisor D you may consider as your main entry point for your Docker containers. So I just mentioned this. I find this piece of software very useful, and we can discuss this in the further, probably offline. Next couple of pieces of the software, it is an in-container decoupling. And what I find for myself, HA proxy, probably many of you know what this is. If you don't, this is software-based load balancer with TCP/IP or HTTP load balancer with the detection of the faults. Or Octopus Load Balancer, it's a bit of the older project. Here is the link. The beauty of the Octopus Load Balancer is that you can interact with this load balancer using the pipe, and you can modify endpoint without starting and stopping and refreshing the configuration. So you can configure load balancer on the fly. So you will need those two pieces. And next, we will start to talk about what the installation will look like. And again, I'm using one of the tasks I've been given by my employer, saying you need to be abstract from the specific cloud provider as much as possible. I will be using kind of AWS terminology, but you can use the same ideas with Azure or any other provider. So first, database, very important. Never ever think about deploying single instance of the database. Because if this database goes down, yes, Zabbix goes down. In my experience, 3 database in master configuration is what's generally required. Next is all about computing. So your Zabbix is the application. It does require CPU and the memory in order to be operational. So again, you see 3 parts of the same VPC. I'm specifically pointing you to the fact that it is extremely important not to put all the eggs in the same basket. Most of the cloud providers giving you multiple availability zones. So you need to deploy your database and computing resources in the multiple availability zones. Next, what you must have is distributed resource manager and discovery. This is to mention, since the Zabbix is pretty much a legacy application, the software that you choose to run the Zabbix on the cloud must support old-style Unix legacy applications. And DNS. I need to mention this a little bit. DNS is generally used by modern cloud deployment software as the mechanism for resource discovery. Later on in one of the slides, I'll show you how this works. And now, basic approaches to the deployment Zabbix on the cloud. So here, first, you deploy a Zabbix server. You will require DNS service discovery and through HA proxy, which will send your request to one of the instances of the database deployed in the different availability zones. So in order to deploy the basic Zabbix server, you actually need multiple components. Next, Zabbix proxy and Zabbix JMX gateway. Again, you will need service discovery for the Zabbix proxy in order to find where your JMX gateway and the Zabbix is located at the specific amount of time. Because if the node in your computing pool is down, the software will migrate your server to the surviving node, and IP address and everything will be changed. So DNS service discovery will take care of that problem. A JMX gateway, again, pretty much for any pieces of your Zabbix component, you will need a service discovery. Never ever think of using statically defined host names or IPs. Like, forget they are existing. Same for the agent. I find for the cloud deployment, active agent covers most of the situations. So if you can, please do use active agent because, again, service discovery will help you greatly with that. And front-end UI, again, here is the Zabbix front-end. Through the service discovery, Zabbix front-end will find out where the Zabbix server is, and through HA proxy, pretty much same or similarly configured HA proxy as for the server, it will find where is the pool of the databases are located. And of course, a front-end load balancer, you gotta have HA proxy in the front of the pool of the front-end. Don't even think running a single front-end in the cloud deployment. So please do run a multiple front-ends. So solution number one, Mesos, Marathon, Docker. That's the cookie cutter solution for running something on the cloud. It is a bit more challenging, and what I find for myself, it's much easier to stay with the Mesos Marathon solution and don't go into the DCOS, which is for our specific application for deploying the monitoring platform. It's overly complicated. So stay with the Mesos Marathon and the Docker. The beauty of the Marathon, which is the part of the Mesos, is it does support legacy applications. A bit of the knowledge about resource discovery. So resolver querying the cluster state, sending updates to the slaves, and feeding the discovered name and IP combinations to the DNS service. That's how you discover the resource on the cloud. If the resource changes the location, you will automatically get the new IP. Also, you will need Zookeeper, which is required for the Mesos Marathon, and your overall configuration may look like this. 3 availability zones. That's the computing infrastructure controlled by the Mesos, MySQL in each availability zone, and Zookeeper in each availability zone. The next solution is Nomad Consul. Again, the beauty of this solution is it does provide you the support for the legacy application, and the Consul provides you out-of-box resource discovery. Links are provided. And again, in both of those solutions, it would be nice to deploy your legacy application inside the Docker container, although it does not strictly require. You can skip using Docker for the both solutions. And your second solution may look like this. Again, different availability zone. You have MySQL server in each availability zone, and you have a computing infrastructure in each availability zone. Very important, who will watch the watcher? I'm almost done. I find out of my experience that if you deploy, and many people deploying even this, and they are happy and they think they achieve success, where in fact they does not. What will happen if this infrastructure goes down? Who will tell you that you have a foobar? Nobody, unless you deploy alongside small Zabbix installation, which will monitor your main Zabbix infrastructure. And of course, your main Zabbix supposed to monitor this mini Zabbix. And in this situation, if your main Zabbix goes down for some reason, you will at least have somebody who will tell you that fact of life. If watcher disappears, at least you have your big Zabbix, which will tell, hey, fix the watcher. And support infrastructure, of course. Think about this. Zabbix is the last piece of your kingdom, which is supposed to go down in case of catastrophe. Everything Zabbix need to get running, DNS, Docker repositories, everything. You need to be self-contained for your Zabbix infrastructure. Don't even think to put your Zabbix depending on other parts of your infrastructure. Zabbix is supposed to be, I don't know, North Korea comes in mind as the example. Absolutely, unquestionably self-sufficient. No dependencies, don't even think to use any external dependencies for your Zabbix installation. And last but not least, security. Please do safeguard VPCs. Please do control which traffic you pass through the VPC's border. Encrypt your data. Please do remember that the configuration files contains the passwords. Please take care of them. Put them in the vaults. Store them in encrypted form. Oftentimes I see that people miss that entirely. And this was my lessons from how you deal with the cloud. Now I'm open for your questions. Yes, who is first?
Questions from the app?
Yeah.
Is high availability proxy best practice for load balancer? And do you try to use Nginx as load balancer?
What I find, so again, this is a situation, there is no right and wrong situation. Nginx is also a good solution for the load balancer, but I find HA proxy is much more slim solution for that. So it requires less resources and works equally well. That's the only explanation why I recommend HA proxy, and it's been thoroughly tested. It's a good solution.
Okay,
thank you.
Did you try to use Docker container with Zabbix server?
Yes, I did, and in fact, why I keep talking about legacy application support, I find out that I didn't find any substantial benefits for running Zabbix inside the containers or in the legacy mode. So depends on, like, if you have a good team who do understand how Docker works, it is a good idea to deploy Zabbix in the container, although it strictly doesn't require it.
And my question is, maybe you know about performance degradation of Zabbix in Docker container, or it's not getting any effect on performance?
Yeah, in the installation, I've been managed through this. I tried both. I tried in legacy mode and I tried in container. And I ran this on example of 200 nodes during that proof of the concept. I didn't detect any significant performance benefits or degradation in either this and this. I believe when you will run the server on the larger installation, container engine will steal some of the resources from the node. It will. But I guess you need to load this node sufficiently before this happens. And of course, when you will plan your deployment for the Zabbix server, you need to tag the node on which you run the Zabbix server. It's supposed to be pretty powerful nodes. And again, the beauty of this, you can always scale out. If the node starts to fail due to the lack of the resources, you can deploy the new node, add to the cluster, and migrate the Zabbix server to the new node.
And my last question, what about Zabbix proxy in your architecture of?
Again, Zabbix proxy, in fact, when I done the proof of the concept, all the proxies were running inside the same cluster. Consul Nomad, particularly good for managing multi-zone affair. So you can span your cluster across the multiple zones and run your proxies pretty much everywhere. You can tell to the software, like, gravitate to those stacks. And yeah, the idea, in the Mesos, there is idea of the stack. But again, you need to change your way of thinking from, hey, this is dedicated hardware that I'm using for my deployment, from, hey, this is the pool of the hardware I can use at any time for running something. Yes, sir.
So we have some questions from Slider first, and then we will give you.
Yeah, thank you. Why do you utilize a mix of a cluster-controlled and non-cluster controlled components?
Because, for example, MySQL, I'm still in fraction, shall be MySQL controlled by the cluster or not. In this example, I find it's much easier to remove the complexity of the cluster deployment for this resource-heavy application and rely on a load balancer for reliability. So again, it's all about simplicity. So if I can remove some of the components without losing any benefits, I tend to remove the unnecessary components. But again, in this situation, there is no right and wrong. Like for example, in the Mesos, you can try the project Chamomile. If I remember well, it's still in the beta, but it will give you the containers with the MySQL inside them. I have my doubts they will work well with the Zabbix, but you can try.
Okay, one more question from the audience.
Thank you. You were talking about AWS. We also use AWS very much, and we have over 100 servers or something like that. Do you monitor the AWS resources by Zabbix? Do you use any tools? For example, volume, snapshots, using CloudWatch, something like this. On the AWS level, excluding any server that uses the volumes, for example, or the IP address, addressing the AWS infrastructure directly from the Zabbix server.
Of course, you got to do this. I mentioned the mini Zabbix server, which watches the watcher. One of the prime responsibility of this server is to monitor AWS infrastructure, which involved in the functioning of the main cluster. You got to monitor everything: the status of the volume, status of the nodes, through the CloudWatch, through the Zabbix agent. If CloudWatch doesn't give you something.
Thanks. But to address the AWS resources directly, do you use any tools? Maybe this is not included in Zabbix. It's Amazon API.
Yes, it does not. It is a several off-the-shelf community solution. In my POC, I was using my own tool inside which I'm using Boto, and I'm using the loadable module. I was talked, I think, a year ago about this loadable module. So I'm load Python module inside the Zabbix server, inside which I'm running the script, which talking to the AWS using Boto.
So it's script-based items in Zabbix, right?
Yes, that's pretty much it.
Did you use LOD for this low-level discovery?
Not to extent, at least not for the proof of the concept that I was working on, but hey, the bigger deployment you do, the more complicated it will become. Like I say, my point is not like teaching you like what's right and what's wrong. It's rather saying, hey, that's the approach.
Well, that's your experience that
Yes.
is interesting to us. Thank you.
And I think I'm the last person who is staying between you and lunch. Do you have any other questions? Well, don't blame me.
Hello.
One last question from here.
Over here. I suppose the last and quick. Am I correct that on your pictures you have like 3 clusters, like Zabbix server plus MySQL?
Mm-hmm.
So what happened with the history? What happened with events if you have like 3 clusters? Does it take any replication between or?
Well, in case of the failure, that's what's going to happen. So this is 3 independent MySQL server. I'm using Percona for master-master replication. And when I configure HA proxy, which will balance, it will not be balancing between all the queries between 3 of them. It will using 1 if failed the second, if failed the third one. So if the one is failed, all the traffic shift to the next one. Yes.
Okay, so one very, very last question from Rafael.
I'm sorry. My question was, what is your experience with running a multi-base database on different locations? I'm thinking of performance penalty and the stability of that. Especially the performance when you have to replicate.
Multi-base. Well,
multi-master in different locations.
Yes. You will pay penalty for multi-master database for the network. You will pay that penalty, and the bigger database, more metric that you control, the larger replications will be. So that's why I do recommend to run all those databases inside single VPC. Inside single VPC, but on the different availability zones. I'm not at this point of time recommending to split them between the regions, because between regions I have gut feeling that replication will not keep up. But if you stay within single VPC, you will be fine. How to achieve multi-region reliability, it's a totally different topic. You probably can just for that purpose establish master-slave replication on the host installed in a different region without like automatic failover. That's the first thing which as of now comes to mind.
So thank you very much for your questions. Thank you, Vladimir.
Thank you, ladies and gentlemen. Thank you.